Okay, so today we are gonna start the problems on the linked list. So this is a question that let's discuss middle of a linked list, and we will understand what is middle of a linked list, and also we are gonna talk about how to approach this problem. What are the approaches for this problem? What is the solution for this problem? We'll do a dry run for this problem, and then we will have some sort of a pseudo code, and then we will solve this problem on lead code, right? This is a problem number lead code for 876. This is a nice number, I would say. And it's here is this question. So we can read this problem here, and then I will discuss this problem on the whiteboard. So we are given a head of a linked list, right? Head is the starting point of a linked list. And then we have to return the middle node of the linked list, right? And if there are two middle nodes, we have to return the second one. So let's consider this example. Was given to us. Let's say one, three, poet, one, one, three, four, five, six. So what is the middle, right? We will remove this, right? This, this, this. So the middle here is three. Okay. Let's consider one more example. One, two, three, four, five, six. So this is a case where the length is odd, right? And this is a case where length is even. So we are given that if there are two middles, right? This and this are eliminated, this and this are eliminated. So now we have left with two middles, right? So we have to take the second one. So four is the we have to consider the middle in our problem statement. So there can be certain cases where we have to consider this as well in some different problem statements, but usually this is given. So these are the two cases which we have. So some people can say that for this case, one, two, three, four, five, like this. We can find this. I'm just talking about the approaches, how we can approach this problem, right? So when we can be that I calculate the length. What is the length? We can see that it is a five length, and then what will the middle element? Five divided by two. What we get? We get 2, right? Because it will give it 2.5, and 2.5 will eventually return us 2. So we can say that if our pointer is pointing to this is head, then we have to move two places from here. So 1 and then 2. It will be at 3, and then we can return this. This will be our answer. And in this case is when our length is even. So here the length is 6. So 6 middle will be 3. So now we have to jump 1, 2, 3. This works, right? This approach works. So you have to, but there is a challenge in linked list, right? It is not an array that you have a, you in the problem statement, you are not given with the length. So to find the length, you have to traverse all of the list, right? Let me just draw it up. So let's say there is this one, then one you will go to two, three, four, five. I'm taking a longer list here. Six, seven. So if it is like 7 here, so first we will count, right? We are not given the length, so I will be here, right? Head. So I will move to the next one, then I will count this because initial counter is 1, right? Then I will move to 2, so length will be 2. Then I will move here 3, 4, 5, 6, 7. Until unless I found that next is null, right? Till the place I will move. So the counter will increase by plus 1 at each iteration until I encounter that the next is null. So the length will be 7, and then I will divide the 7 by 2, which will eventually give me 3, and then again I will traverse to 1, 2, 3 again. Then it will return with a middle element, right? So we have traversed the linked list by n iterations plus of n by 2. So these are just the notations which are used to denote the time complexity. Here the time complexity is certainly of n plus of n plus 2. Let's see another approach which we can have to solve this problem. Let's consider this example itself. 1, 2, 3, 4, 5, 6, 7. So here is this approach, right? The approach is like this. Let's do this color. So this is my head, right? Usually we don't move head, we keep head as it is, which is given in the problem, and then we will add two more variables to it. I will add, let's take a better. So let's say I will add here uh, current, previous, right? Let's say slow or fast. So I will add a fast here and I will add a slow here. So the intuition for this approach is like whenever uh you know something will move from here to here, so intuition is like this. Intuition for this is like this. So let's say you have yeah, consider this. There is 100 kilometer, or 100 is too much. Let's say there is a 10-kilometer race, right? And your friend is moving twice the speed of you. So if you are moving 1 kilometer in 1 hour, right? 1 kilometer in say 15 minutes, right? So you will, or let's say you are moving 10 kilometers in, sorry, you are moving 1 kilometer in 10 minutes, and your friend is moving 2 kilometers in 10 minutes. So he is moving twice as fast as you. So when he will complete this race, it will take him 5 minutes, right? 5 into 10, it will complete this race in 50 minutes, 5 times, right? And you will complete this in 100 minutes. So, and by the time he completes this race, you will be at the middle point, right? Let's say this is a circle and this is a 10-kilometer track. So he's moving twice as fast as you. So if he's moving twice as fast as you, he completes this in 50 minutes, and by the time 50 in 50 minutes you will be at a point here, right? Middle point, right? You will be here 50 minutes, because for you it's gonna take you 100 minutes to complete. You're right, 100 minutes to complete. So by that 50 minutes you will be at a half position. So we can say that if a person is moving twice as fast as you, you're at the middle point, right? So it's the same intuition. I will take a fast pointer, I will take a slow pointer, which is both pointing to the initial points, and then fast will move twice as fast as the slow one. So in one iteration, I will move this to second, and then it will go to the third place, right? And the slow guy will move to the second place. So he will just move here. It will come to the 2, and this guy has moved to the 3. So now again he has moved to 5, and my slow guy has moved to the third position, right? And then by the time he moves to the last position, right, my slow guy will be at 4, right? A will be at 4. So now what I can say, I can conclude from this is right. By the time the fast guy reaches the last position, my slow guy will be at the middle of the linked list, right? So if you see, this is not anything. This is the middle of the linked list, right? Remove this, remove this, remove this. This is middle, right? So we have achieved this n of n, big of n. So big of n means in a single iteration. In a single iteration, I have achieved this. So I have this approach. Let's try run one more problem. So let me take one, two, three, four, five, six. So this time I have taken even length, so I can depict right what how we are moving. This is my head. My fast is also at here. My slow is also here. And now they will start. So slow will be moving to 2, fast will be moving to 3. Slow will be moving to again 1, 3, and fast will be moving to 4, 5, right? And then slow will be moving to 4, and then we have 13 left. This will move to 6, and then it will move to none. So from here we came to know that we have to move this until unless my this is at the last position or to the null, right? Now from here we can't move any further, right? So this is our answer now. We can also stop here itself, uh, or we can move it to simply here. It's up to the code we move because we can move till the null pointer, right? So this is how slow and fast are gonna work. So what is the pattern to solve these problems? So first you have to have a understand the problem, understand understand the problem. Second is like have a approach. So if you are gonna tell this like this in the interview now, the interviewer will be very impressed with you. And then third, by approach you have to also tell the time complexity and space complexity of the solution. So here the space complexity is that we are not using any right. We are not using any extra space. So space is my big of one only. So and then we have to approach we can dry run and all these things, and then we have to find the edge cases. What can be the edge case? So in my problem, maybe I'm given with the empty list. My head is itself null. So what will I do? There is no way to move. So I will just return my head, right? And maybe there is just only one element in my list. Then also this will be only middle element, right? So then also I will say the answer is head. And if there are three or four, our even logic will work. Then we can say that this will be gone, and then you can return the middle element, whatever it will be. So if this is head and head of next is this, then this will be the middle element, right? 4. So that way we can compute. But now I think the problem is much more clear, and let's code this up. What is the approach we are going to follow? So that's I'm saying if we are given a head and that thing. So if head is null, right? Or head next is null, I will say they will return this head. Clear? We just said this edge case, right? We have just coded this edge case here, and then we have to code this our approach. So what I will say, what I will do here, just remove this, and now I have a note. I will say that fast is also pointing to head as discussed. Slow is also pointing to head, right? Now how far we have to go? we have to move till fast is not null, right? Or and we can move till fast next is null, is not null. Till then we have to traverse, right? We have to traverse our linked list. Then only we will find the then only we will find this middle. So if I will what I will do, I will move my slow to slows next. Very clear. We discuss this. And then fast to fast next. But then my fast will move to two places, and let's say my fast is at a certain place where it is like this, right? My fast is here at 6, and my fast is here at 6. So fast next, let's say my fast started from here. My fast is here at 6, and my from 6 it can move to null, right? But from here, if I try to move to the next place, nulls next, I can't access the nulls next because null is I don't have a memory to it, so I can't move here. So I will add a safety check here that if the fast is null, right here it is null, then I can't move, right? So what I will do, my fast should definitely not be a null to move it to the next point because my fast will move two places and slow will move only one, right? So this will go to next here like this, and then this is my code for my while loop, and then here I will return my slow pointer will have a return, right? Answer, right? Slow, I will return slow, and then this will be the pseudo code, right? You can have a look at it like this. So this is the answer, I would say. And let's code this up. I hope this is clear to all of you. And now just quickly code this up because I think the video is getting longer a bit. So what we decided, right? Edge cases first. So head is null or head of next is null. Then I will return my head itself, right? And then I will have two nodes list star. I can use head itself as the place of fast, but the recommended approach is that we should have a head separately because I will lost the starting point of my linked list if I don't have a head, right? So I will have a fast here which is also pointing to head, and I will also have a slow which is also pointing to head, right? Now I will say while my first is not equal to null and my first next is also not null, then I can say that I have to iterate, and then the return is slow as we all know, and slow will be moving one place. Sorry, oh, and fast will be moving two place, right? Fast like this. So move two place. I can also do that next of next. I can also do here. If I also do, I have a safety check here. It will not impact much. Let's try this because I have not tried it. My if condition here. I'm sure it can give certain. There can be certain cases which can give a pointed error here. Let's try this out, right for this demonstration. The test cases which are given here pass successfully. Awesome. Let's submit this code for review, and this also run perfectly because we have we have the case here. If I didn't have this case, right, this one, then it will crash because if the fast is null itself, we are not accessing it. So this is a good, but we can also have the safety check here. You can tell your interview. He will be very impressed with you. So that's all for this video, guys. I hope you understand this. If you have any queries, all ears. Drop a comment below, and please like, subscribe, and comment on the videos. It means a lot. Thank you.